friends, welcome you all to Think Max. We are in class 11 Max, chapter 3, Trigonometric Functions. In this session, we are going to discuss about the example problems 6 to 9. So these problems deal with finding out the trigonometric functions. That is sin x, cos x, tan x, cot x, secant x, cosecant x. So we have to find out the values for those trigonometric functions. Okay. So let us say example 6. If cos x equal to minus 3 by 5, x lies in the third quadrant. Find the values of other 5 trigonometric functions. Okay. So what are the other 5 trigonometric function? Yeah, we know that it is sin x, tan x, cot x, cosecant x, secant x. We have to find out those values. The only value given here is cos x value. It is minus 3 by 5. Okay, so this value is given. We have to find out the other values. So what are the other things given? X lies in the third quadrant. Okay, let us know how the values will be in all the 4 quadrants, x-axis and y-axis. So this is the first quadrant, second quadrant, third quadrant, fourth quadrant. What trick did we learn from the previous videos? Did you remember? Okay, just I will say it is nothing but add sugar to coffee. That means A is for all, S is for sin, T is for tan, and C is for cos. The first quadrant is 0 to 90 degree. So this is 90 degree and it is 0 degree, 90 degree, and this is 180 and this is 270. Again it moves on, completes one cycle. So it is 360 degree. Okay. So this quadrant is 0 to 90 degree. Here all are positive. Okay. All trigonometric functions are positive. Clear? Now here add sugar. Second quadrant is sugar. That is S for sine. Sugar, yes, and S is for sine. Here sine and its inverse. Who is that? Cosecant. They both are positive. Okay. Now come to third quadrant. What we have? 2. T is for tan. So here tan and cot. Tan inverse is cot. They both are positive. So this is 180 to 270. Second one is 90 to 180. Okay. So now fourth one. Fourth one stands for coffee. So C is for cos. So here cos and its inverse secant. They both are positive. Clear? Now we learned who are all positive in all these 4 quadrants. Clear? Now with this we have to find out the values of sin x, tan x, cot x, cosecant x, secant x. Okay. So it is very simple. Let me start the solution. So first what is given? Cos x is minus 3 by 5. Okay. So this is minus 3 by 5. Next we can find out easily its inverse. Who is its inverse? Secant x. Secant x is nothing but 1 by cos x. So it is 1 divided by minus 3 by 5. So when it goes to the numerator, it will change as minus 5 by 3. That is 1 into minus 5 by 3, just minus 5 by 3. So secant x value is minus 5 by 3. So we found 2. Next we have to find out the other values. How we can find? Cos x is known. So the only thing, if you find sin x, cos x, easily you can find out the other values. So to find sin x, we know the relation sin square x plus cos square x equal to 1. You learned this in the 10th standard. So we have to find out sin square x. So sin square x is equal to 1 plus will become minus on the other side. 1 minus cos square x. So 1 minus, what is cos? It is minus 3 by 5. So it is minus 3 by 5 whole square. So 1 minus, this minus square is plus. 3 square is 9, 5 square is 25. So it is 1 minus 9 by 25. So we will take the LCM as 25. So it will be 25 minus 9, which is 16 by 25. Now we need sine x. So we got sine square x equal to 16 by 25. So taking square root, sine x will be 4 by 5. But if we take square root, we will have plus or minus 4 by 5. But x lies in the third quadrant. So in the third quadrant, what happens to the sign? Only tan and cot are positive. All the other trigonometric functions are negative. So sine is negative. So sine x takes the negative value minus 4 by 5. So we will get minus 4 by 5. Now we have to find tan x, cot x, cosecant x. Very simple. Who is cosecant x? Inverse. That is 1 by sin x is cosecant x. So cosecant x equal to 1 by sin x, which is equal to 1 divided by minus 4 by 5. So if you take this to the numerator part, it will inverse. That is 4 by 5 will become 5 by 4. So it is minus 5 by 4. So cosecant x is minus 5 by 4. Now we have to find tan and cot. Easy. How? Because tan x is nothing but sin x by cos x. What is sin x? Sin x is minus 4 by 5. What is cos x? Minus 3 by 5. Both the negatives gets cancelled. 4 by 5. This 3 by 5, when we take it to the numerator, it will become multiplication and it will inverse. 3 by 5 will become 5 by 3. So 5 gets cancelled and we will get 4 by 3. So tan x is 4 by 3. What is cot x? It's inverse. It is 1 by tan x. So it is 1 by 4 by 3. So it will become 3 by 4. So cot x is 3 by 4. Very simple, isn't it? So just remember this quadrant formula. Add sugar to coffee and you will know where you will get the plus signs. Okay. So with the same method, we will do the next example in the next page. Example 7. What is given here? If cot x equal to minus 5 by 12, x lies in the second quadrant. Find the values of other 5 trigonometric functions. Okay, clear? We have to find the other 5 trigonometric functions. Who are they? So these are the things. What is given? Cot x. Cot x value is minus 5 by 12. So cot x value is given. We have to find remaining 5 values. So tan x. Tan x is inverse of cot x. So we can find tan x from this. The remaining thing we have to find out from some relations. So we must know if x lies in the second quadrant, who are all positive. What we learned? Add sugar to coffee. So this is first quadrant and this is second quadrant. This is third and this is fourth. In fourth, 4 is positive sign. That is sign and its inverse is positive. All others are negative. Okay, just remember that. Now what is given? It is given that cot x equal to minus 5 by 12. First we will find out its inverse. Who is that? It is tan x. Tan x is nothing but 1 by cot x. It's nothing but 1 divided by minus 5 by 12. So we'll get a negative sign. 5 by 12 will become 12 by 5. So tan x is minus 12 by 5. Next, what relation do we know with tan x or cot x? Do you remember? Yeah, we know that 1 plus tan square x is equal to secant square x. So, now we are in the procedure to get secant square x. So, 1 plus, what is tan x? minus 12 by 5. So square equal to secant square x. So I can write secant square x is equal to 1 plus minus square is plus. 12 square is 144 divided by 5 square is 25. So which is equal to 25 is the LCM. So 25 plus 144. If you add, we will get 169 divided by 25. So we got secant square x equal to 169 by 25. If you take square root on both sides, we will get secant x equal to, whose square is 169? It is 13 square. So 13 divided by 5 square is 25. If you take square root, we will have plus or minus. But where is x? X is in the second quadrant. In the second quadrant, only sine and cosecant are positive. So secant x is negative. So that is secant x is negative in second quadrant. Therefore, secant x equal to minus 13 by 5. So we got secant x, which is minus 13 by 5. Cot x is minus 5 by 12. Tan x is minus 12 by 5. So just three more values. So if you get secant x, its inverse is cos x. So you will get cos x now. Cos x is 1 by secant x. So 1 by minus 13 by 5. So negative sign 13 by 5. When you take it to the numerator, it will become 5 by 13. So cos x is minus 5 by 13. What is the next step? We have to find out sin x and cosecant x. Very simple. Easily we can find out sin x. How do you find out sin x from these values? What we know? We know that sin square x plus cos square x equal to 1. So sin square x is 1 minus cos square x. 1 minus, what is cos? Minus 5 by 13 whole square. So 1 minus 5 square is 25. 13 square is 169. Okay. So negative square will become positive. So the LCM is 169. So 169 minus 25. What value? 169 minus 25 is 144 divided by 169. Now we got sin square x is equal to 144 divided by 169. So taking square root, we will get sin x equal to plus or minus, whose square is 144? It is 12. Whose square is 169? It is 30. Plus or minus 12 by 30. Where does x lies? X lies in the second quadrant. In the second quadrant, sign is positive. So sin x is positive in second quadrant. Therefore, sin x equal to 12 by 30. So we got sin x 12 by 30. So cosecant x is 1 by sin x. So cosecant x equal to 1 by sin x, which is equal to 1 divided by 12 by 13, which is nothing but 13 by 12. So cosecant x is 13 by 12. Clear? Are you clear, children? So I think I have explained all the steps in this. So we will move on to the next example. Example 8. Very simple. Find the value of sine 31 pi by 3. Okay. So now let us write 31 by 3. How do you divide this? 1 3s are 3. This is not divisible. So 0. So 10 3s are 30. The balance will be 1. 10 1 by 3. So this can be written as 10 plus 1 by 3. So we have converted the improper fraction to mixed fraction and it can be written as 10 plus 1 by 3. So 31 by 3 into pi is 10 plus 1 by 3 into pi. So this is nothing but 10 pi plus pi by 3. This 10 pi is nothing but 5 into 2 pi plus pi by 3. So that means it is 5 into 2 pi, that is n into 2 pi. So we know that sin x repeats in the interval of 2 pi. So we are going to use that logic. Okay. So let me start the solution. So we can write sin 31 pi divided by 3 as sin 10 pi plus pi by 3. So 10 pi is nothing but 2, not 2 into, let me write it as 5 into 2 pi plus pi by 3. What we know, sin x repeats in the interval of 2 pi. So we know the value of sin x repeats after an interval of 2 pi. So we will get sin 5 into 2 pi plus pi by 3. It's nothing but repeats, means we can ignore this. We can ignore this 10 pi and write sin. So sin is repeating. So sin, what value is that? Pi by 3. Okay. So sin pi by 3 is nothing but sin 60. So what is sin 60? So sin 60 is root 3 by 2. So therefore sin 31 pi by 3 is nothing but root 3 by 2. This is the solution. Clear? So we have just splitted 31 by 3 as 10 plus 1 by 3. So multiplying by pi, we will get 10 pi plus pi by 3. So 10 pi is nothing but 5 into 2 pi. That is repetition of 2 pi. We know that value of sin x repeats after an interval of 2 pi. So sin will be sin. Repeats means sin will be sin. So we can ignore this and write sin pi by 3. Sin pi by 3 is nothing but sin 60 degree. It is root 3 by 2. So this value is root 3 by 2. Clear, children? So moving on to the last example in the next page. Find the value of cos minus 1710. So the value here is minus 1710. So this number is bigger. So I am going to use here 360 degree. That is 2 pi. 360 degree is nothing but 2 pi. So I am going to write as a multiple of 360 degree format. So let me check for some numbers. What is 4 into 360? 0, 6 4s are 24, balance 2, 4 3s are 12, 1 4 4 0. So that is a large difference. So we will check for 5 into 360. So 5 zeros are 0, 5 6 are 30, balance 3, 5 3s are 50, 15 plus 3, 8. So I think the difference is lesser. So 1800 minus 1710 is 0 and this is 90. So we can write minus 1710. Just to take only the positive. Okay. So not to take that negative sign. Take only this number 1710. So this can be written as 1800 minus 90. Okay. So because the difference between 1800 and 1710 is 90. So 1710 can be written as 1800 minus 90. So who is 1800? 5 into 360. 360 is nothing but 2 pi. So 5 into 2 pi minus 90. So this cos is also coming as repetition of 360 degree. Now let me start the solution. What is given here? The given here is cos minus 1710. What we know? Cos of minus x is cos x. So if you are new to this video, just check my introduction video for trigonometric function. You will find all the formulas. We know that cos of minus x equal to cos x. So cos of minus 1710 degree will be equal to cos 1710. How did we write 1710? 5 into 2 pi minus 90 degree. So cos 5 into 2 pi minus 90 degree. Okay. So we know that the value of cos x repeats after an interval of 2 pi. After an interval of 2 pi. Okay. So it repeats. Repeats means cos value will be the same cos. So cos 5 into 2 pi minus 90 degree. As it repeats, we will get cos the same. So we can ignore this. We can ignore this and write just minus 90 degree. Also, we know that cos of minus x is cos x. So it will be cos 90 degree. What is cos 90? It is 0. So cos minus 1710 is 0. Clear, children? I hope I have explained all the steps clearly. If you have any doubts, you can comment. In the next video, we will discuss the exercise 3.2. Bye-bye.